Hello everyone, and welcome to my talk about Kubernetes Gateway API, and I will be happy to show you the differences between this new API and the ingress API that we used to use until now. Okay, let's get to some presentations, and I am Gregorio Palama. I work as DevOps and cloud engineer at ThinWave, and I am a community manager at the local chapter of GDGs in Pescara. You can find me on social networks, especially on X and on LinkedIn. Okay, let's start with saying what are we talking about? We are talking about exposing our services outside the cluster. Well, note that in this slide and in order in all the other slides, we are referring to services such as the service resource in Kubernetes, and it's done because of simplicity. We can say that until now we use ingress API to expose our services outside the cluster, and that's an API that is globally available since Kubernetes 1.19 and is widely used. Let's see how it works using a way that is known as north-south that depicts the way that traffic goes from our client, the top, the north, to our service. We will see it on the bottom, the south. So let's say for example that our client performs a request to a DNS, myapplication.com, and on that DNS there is attached an ingress called myingress, and that ingress will route the request to our service. Let's say it is called my service. Well, what happens from now on is, for example, my service is backed by an endpoint that collects EPs and ports for our pods that will receive the request and answer with a response that will be handled back to the client. The important thing is the way that the request is routed. Okay, we can see the YAML that is representing the example that we've seen right now. And I added, for example, a way to define a particular path that the ingress can handle for us. Okay, before we go to see the limitation of the ingress API, let's start by reading a small part of the documentation, the official documentation about the ingresses. Well, the official documentation says that the ingress exposes HTTP and HTTPS routes from outside the cluster to services within the cluster, and traffic routing is controlled by rules defined on the ingress resource. Well, first of all, HTTP and HTTPS. The ingress API was designed with these two protocols in mind, no other protocols. Also, everything is defined in the same resource, and that's a limitation that, well, we can see the implication going further in our presentation, because let's see the personas that were in mind when the ingress API was designed. Well, the only personas was the user, the ingress owner, and that's a big limitation because the user had the responsibility to manage the infrastructure configuration, or for example, TLS configuration, and the routing configuration too. Going through the years, a persona was added, and the persona was added because when the ingress class resources was added. Ingress class are resources that contain additional configuration, including the name of the controller that should implement the class. That's what the documentation says. Okay, what does it mean? First of all, we have, as I said, another personas. The user that was the original owner of the ingress resource still has the responsibility of working on the routing configuration. The new personas, infrastructure provider and cluster operator, has the responsibility of working on the infrastructure configuration and on the TLS configuration. Well, this was a nice addition, but still the first design was with just one personas in mind. So this is an addition. It's not been redesigned. No process of redesign was done on the whole API. So we still have other limitations. For example, extensibility. It relies on annotations. We have different implementation of the ingress API, and every different implementation has to rely on the annotation if it wants to add something that is not provided by the API itself. So we have a situation where some implementation created custom extensions. The easier way is to rely on annotation. So we have different kind of annotation, different ways to annotate these extensions from implementation to implementation. And these custom extensions are valid for the single implementation only, and that's a strong limitation. Well, let's get to the Gateway API. The Gateway API is global, available since Kubernetes 1.25 that has been released in October the 31 in 2023. So it's kinda new, if we want to call it new, but it's new if we refer to the global availability of it. The API is available not in global, available since like 2 or 3 years. Well, let's get to the details. API Gateway describes anything that exposes capabilities of a backend service while providing extra capabilities for traffic routing and manipulation and sometimes more advanced features. What does it mean? Let's start by saying that the first thing that was in the mind of who designed this API was the personas. Why is that? Well, we will see it shortly. Let's get to the personas, and we can see that the first personas has even a name. Well, any personas of the gateway API has a name because who designed want to give a strong meaning to the personas. The first personas is called Jan. He's an infrastructure provider. The second one is Chihiro, and he is a cluster operator. And the third one is Anna, an application developer. Well, the first implication of this is that we can refer to these personas and think about them like a single persona, but we can think about them with like teams also. For example, we can have Anna, and that works with her team as an application developer, but we can have another team. We will use the same personas, but we can think about two teams working on the routing that our traffic management system needs to implement. Okay, what are their responsibilities? First of all, Jan, the infrastructure provider, he has the responsibility of configure the infrastructure and can work on multiple clusters. So we see that here the design is totally different because for the first time we are thinking about working on the configuration on different multiple clusters. And the whole API is designed around this kind of possibility. Let's get to Chihiro, the cluster operator. He has the responsibility of configure the entry points. Not only the endpoints, he can only configure TLS and so on. And finally, the application developer, Anna. Well, she has the responsibility of configuring the routing rules. And that's something that is application related because the application needs to mm, perform the routing rules and the application guides the developer. Well, it has its intrinsic needs. So the application developer is the only one that really knows how the routing configurations should be done. So we can see a separation of concerns that the ingress API doesn't provide, but the gateway API provides. And that's a great thing because every team, every personas can think on its own responsibility and its own concern while he or she works on their works. Okay, let's get to the resources. The first resource of the gateway API is a gateway class. It defines a set of gateways that share a common configuration and behavior. And each gateway class will be handled by a single controller. The gateway class is a resource that is cluster scoped and it is somehow similar to the ingress class for ingress. The second resource is the gateway itself. It describes how traffic can be translated to services within the cluster and defines a request for a specific load balancer config that implements the gateway class configuration and behavior contract. So the gateway class configuration will be will configure a behavior, and the gateway defines a request for that specific behavior. It may be attached to one or more route references, so we can have a way to define security boundaries that the ingress API didn't provide. And it is possible to limit the routes that can attach to a gateway. The third resource is routes. Routes define protocol-specific rules for mapping requests from a gateway to a Kubernetes services. In version 1 Alpha 2, there are 4 route resource types that are included. And a route can attach to one or more gateways. As I said, the possibility to be attached can be limited, and filters and advanced rules can be applied on the route. Well, I said that there are 4 routes in the actual version. The 4 routes are these ones: HTTP route, TLS route, TCP and UDP route, and gRPC route. As we can see, we have HTTP route and TLS route that maps the HTTP and HTTPS capability of the ingress API. But we also have TCP and UDP route. Those are two protocols that are not available in the ingress API. And we also have gRPC route that is another protocol that was not available in the ingress API. And we have a bunch of new functionalities with the Gateway API that we didn't have with the Ingress API. Okay, as we seen in the Ingress API, let's get to the north-south depicting so we can understand how it works. Let's start from our client that sends a request to myapplication.com. In this situation, we will have a gateway called, for example, my gateway. With the ingress API, we had a my ingress. The gateway, the gateway implements a gateway class that defines all the rules and all the behaviors and the controller, for example, that will be used to implement that gateway. And the gateway itself asks, sends the request to the route. In this case, I call the example route my route. It will have his particular rules defined, for example, from one or two or more teams. And these rules will define how the route will route the request to the service or the services inside my cluster. Well, from now on, it will be handled the same way we've seen with the Ingress API. What's different here is everything that comes before the service resource. Okay, let's get to the examples. First of all, the gateway example. We can see here a gateway called my gateway in the namespace gateway API NS1. It implements a class that is called my gateway class. And for example, we have a listener that is called my application, and we can see here that we are limiting the route that can attach to this gateway. In this case, we said that on this gateway can attach only an HTTP route. Not only, we also said that to this gateway can attach a route that is in the gateway API NS namespace 2. Let's get to the route. This is an HTTP route, so it can attach to the my gateway, and it is in the namespace gateway API NS2. So it is everything that is defined as a loaded route. So it respects these limitations. It is an HTTP route. It is in the right namespace, so it can attach to that gateway. And it has some specifications. The parent refs, it is defined as a kind namespace and name, kind gateway. So we are defining on which gateway it is going to attach, and it is going to attach to the gateway called my gateway in the namespace gateway API NS1. We also define some rules, and in this case, we also define the service that backs. It is the backend for this route. My service on port 80. Well, it's a very simple, easy example. Let's get to some maybe more complex, even if we are still in a simple example. the same route, but with different rules. In this case, we have, for example, two services, my service and my second service. But here we are giving particular rules that define the weight. In this case, um, 1 time out of 10, the route will route the request to my second service. So we have a 10% of the traffic that will be served by my second service, and all the other traffic will be served by my service. That's easy. We have a load balancing strategy directly on the route, and and it can be done directly from the application developers. Let's get to more complex rules. In this case, we have only service that runs as the backend of this route, but we have different matching rules. In this case, we have a neither that should match, and the match should be exact. So we need a neither that is called conference and with a value of conf42. And also everything that is requested on the path /sum/thing will be routed to my service. Still another example. In this case, we also have filters. Filters allows us to modify, for example, our requests, some fields on the request. In this case, we are modifying the request, adding an either, and the either that we will be adding is the my dash header, and it will be have a value of conf42. Okay, let's get to a demo. And for the demo, I will be use a cluster that is served by Google Cloud platform. So I will use Google Kubernetes Engine. And as we can see from the documentation, we have different gateway class that are served by the platform itself. And we can choose one of these if we want to create a gateway, and we can use one of it to implement a gateway. I will use this one, global external managed, because it gives me an external IP, and it gives me a load balancer that will balance every request. Okay, let's get to our example. And first of all, let's create everything that, okay. We are going to create everything that we will need to see how this demo works. And for example, I will create two pods, pod 1 and my pod 1 and my pod 2, two services, my service 1 and my service 2, a gateway called my gateway, and a route called my route. Okay, let's get to see what's inside the definition of my gateway. We are using the GTL7 Global External Managed, and it's just a gateway with a listener on port 80 and protocol HTTP. Okay, let's get to the route. And we can see here that the route is attached to the gateway called my gateway, and we have some matching rules, and we have configured two paths slash one that will route the request to my service one, and a slash two that will route the request to the service my service two. Okay. What we can do here is, first thing, let's get the address, and okay, we have that address that it is the public IP or of our gateway. It is given by the platform, and we can use it to perform a request. We configured two routes. So, for example, we can see something like this, and slash one. Let's get, okay. We can see my pod one. The two pods are the same container, and the container is a simple one that I created that just prints out the host name. So in this case, we have a my pod one. Let's try the other route, two. Okay, we have my pod 2. That's because I used the same container but for two different pods called my pod 1 and my pod 2. But what happens if I perform a request to the root uh, address? Well, I didn't configure any route for that path. So a false filter abort will be received as a response. That's perfectly normal because I didn't configure anything for that route. Okay, what we can do here is, for example, adding, let's see what's inside of it. Okay, I created some tests, and this is the fourth test that I created, but it is the most interesting one. For example, I configured this path slash three. Oh, I forgot to mention this filter. It is valid for the other path too. It just says that everything that is in the path will be replaced because the application inside of the pod answers on the root path. So if we have for example, slash one, it will be translated to slash before it will be routed to the service and then to the pod. In this case, it's just the same, slash three as the path, but the 20% of the traffic will be sent to my service one, and the 80% of the traffic will be sent to my service two. What we will see, or what we will expect to see here, is that two out of 10 requests will print my pod 2, and the other ones, oh no, my pod 1, and the other ones my pod 2. Okay, let's apply it, and let's see what are the results. Let's wait for it to be configured, and okay, we also have our my route 4, and what we can test is that path slash 3, we had the, okay, let's add the path 3. We can see my pod 2 as the answer, and it is in this situation. So that's the 80% of the traffic, but let's try to send more requests, and we should see my pod 1 too, and let's get to, yeah, here we are. So the 80% of the traffic is backed by the my service too, and the other 20% of the traffic is backed by my pod one, so the service my service one. The interesting stuff here is that we have two routes, my route and my route 4. And that's interesting because we use the same gateway, but two different routes. And that's something that we can think about in the real world, mm, like if two different teams working on, for example, two different microservices of the same application that configured the different routes and not only 1, 2, and 3 path, but a whole subset of paths. And they created an HTTP route to uh, perform or the rules for that microservice, for the single microservice. And the two teams created the two routes that are attached to the same gateway. So we have Chihiro that will configure the gateway. So the cluster operator working on the configuration of the, for example, single DNS, but the single team working on the single microservice configuring all the routes for that single microservice. And that's a great step forward in the possibility of separation of concern when it comes to the security level of the things that are served by the API. Okay, let's get back to our slides, and we've seen a live demo, and let's get to the next interesting feature of the Gateway API, the Gamma initiative. Gamma stands for Gateway API for Mesh Management and Administration. And basically, it is an initiative that allows the API to work not only north, south, but east, west too. So for the mesh, the communication between the services. Okay, what we have here, the Gamma initiative introduced three. We can call them two, but they are basically three changes. The first change is that a route can be associated directly with a service too. We've seen that the parent ref was a gateway until now, but we can also define it as service. We can so define the kind service and indicate the name of the service as a parent ref of a route. And also, the Gamma initiative said that a service has two facets, a front end and a back end. The front end is a combination of the cluster IP and the DNS of the service. The back end is the collection of the endpoint IPs. So every IP that the endpoint that is backing the service is called backend, the backend of the service. Okay, let's see how the traffic is handled by seeing the east-west graph of our traffic. In this case, the request is not done by a client, but the client in this case is a pod, another microservice, for example. So the pod asks for a service, and that's the particularity. The pod still performs a request to a service, but here we have three different scenarios that can happen. The first scenario is the service has no routes attached to it, but it still have an endpoint. So the request is routed to one of the P buckets selected by the endpoint. That's the standard way of the function of the service and its endpoint. The second scenario is the one where we have a route that is attached to my service. So we have the my route that is attached to my service, but there is no path that is defined in my route and matches the one that is requested to my service. In this case, the request will be aborted. The third scenario is the one where there is one or more path that is defined in my route and matches the one that is requested to my service. In this case, all the rules inside my route will be executed and the request will be sent to the endpoint backing the service that is defined as the backend inside my route. In this case, we see that the request is handled to the endpoint and not to the service, but directly to endpoint. It is the default behavior. We can define that it still should route the request to a service. It's clear that it should be a different service and not my service. Okay, let's get back to the general discussion about the Gateway API and talk about the implementations. The API is a set of rules, of design guides. The actual implementations are different ones, and not every one of them are global available. For example, the one that I used, the Google Kubernetes Engine, is global available. Kong is global available, but we have some implementations that are not global available and are in beta stage. For example, Apache AP6 and Istio. At this link, we can see a list of implementation with their maturity level. Okay, and let's get to the takeaways of this talk. First of all, the Ingress API will not be deprecated. It's a great API. It works and it worked until now. It will not be extended or enhanced, and that's one of the limitations that brought us to Gateway API. So we can still use it, but let's take in mind that we will not see any new implementation, any new extension. The Ingress API has an insufficient permission model. Okay, we used it until now, and we somehow maybe someone decided that there is a shared responsibility on the ingress resource. The ingress class helped introducing another resource that is maintained by a different team instead of the application development team, but still the Ingress API has an insufficient permission model. The Gateway API permission model with the three personas is definitely better than the Ingress API one. And we have a new role-oriented and extensible and portable and very expressive API, the Gateway API, and we can use it. And it has different good implementations. And all of them adhere to the standard, and we all will always adhere to the standard because the standard is definitely extensible. So what we are saying here is that we should not stop using Ingress API because it is evil. It works great. It just has some limitations, and those limitations are not in the Gateway API. So that's why we should start using the Gateway API instead of the Ingress API. Here we can find some useful links starting from the website of the Gateway API with the official documentation and some example with the mm, API and with the Ingress API. And you can also find a YouTube channel with some videos, some official videos from Google that talks about the Gateway API and gives us some example on some specific topics. Okay, we are at the end of the talk, and here you can find a feedback form and that I kindly ask you to submit because you know every good talk becomes good because of the feedbacks. It's not designed to be good from the start. It becomes good and great. So if you want, and I will be very grateful to you if you want to send me some feedbacks. And that's the end of my talk. And I thank you for following me. And I really hope this talk will be useful, and the concepts that I talked about will be uh, useful for you. And let's hope that you will switch to the Gateway API very soon because it is really great. Thank you and bye.